Matrices. Today we're going to talk about what matrices are and the basics of how to recognize them and talk about them. So a matrix is a rectangular array of expressions. So an array is just some sort of grid, and expressions meaning algebraic that we have. Well, not necessarily that they're all algebraic, but they could be numbers like 2. They can be functions like f of x. They can be algebraic expressions like x minus 7. They can be trig functions. Pretty much any simple scalar object can be a single element. You'll notice that it's in a rectangle. It has to be that every element has things immediately to their left or right, and above and below. They can't have like something randomly in the middle here and nothing above it. The dimensions or order of a matrix are named by the rows by columns. So there's always an x between them. We're not going to multiply them out. But how many rows are there? There's 1, 2, 3, 4 rows. And how many columns? 1, 2 columns. So we call this a 4 by 2 matrix. So if we want to name the order of these, this is 2 rows, 2 columns, so this is 2 by 2. This is 3 rows, 1 column, so 3 by 1. This is 2 rows, 3 columns, so 2 by 3. And this is 1 by 1. Individual entries in a matrix are named A sub ij. I used the word sub between saying the A and the ij to mean that it's the subscript. A comes from the fact that it's from a matrix named capital A. So typically the whole matrix will be named by a capital letter. Each individual entry will be referred to by the corresponding lowercase letter. The I stands for the row number, and the J stands for a column number. So, if we wanted to talk about this, typically we assume we can give a name to this matrix, or we can just call it A. And I would call this, okay, this is in row 1, 2, 3. And then column 1, 2. So this is A32. I wouldn't call it A32, A sub 32. If for some reason we have a matrix that has more than 10 rows or columns, we would write it as A3, 2. But typically people shortcut and just write 3, 2. What is entry A24? So we want the second row and the fourth column, 1, 2, 3, 4. These are all measured from the top left. So this is the first one, second one, this is first, second, third, fourth. So 6. We would say A24 equals 6. We call a zero matrix a matrix with all entries equal to 0. So this is an example of a zero matrix, and it works in many cases the same way that just the number 0 works. But we would also call this a zero matrix. These matrices are not equal. They don't have, in order to be equal, they have to have the same order and the same elements. And the identity matrix is one that has 1s for every across the diagonal and 0s everywhere else. So this is an example of the identity matrix. Thanks.